right, so we're going to do some more review of your own basic skills. Your own basic skills have got to be well above primary level. We've spent time on fractions. You must solidify your own fraction skills. And also now we're going to talk about long division. If there's two things that students dislike in arithmetic, it's fraction math with the common denominator, especially for division, or not for division, for addition. And then the second thing that students dislike from arithmetic is long division. And long division just doesn't go away. You have to learn how to do long division, then you have to apply long division to decimals, then you have to do a lot of long division when you do percent math. So division is an important arithmetic skill. And by division, I'm talking about long division, okay? And long division involves a little bit too much trial and error. Think about when you do a long division problem and you end up erasing the quotient and having to move it up one or drop it down one. So that's because you don't estimate very well. And so you're spending too much time on doing your division, too much time on trial and error, and then you're getting the problem wrong and it's taking you too much time, and that's because you've never really learned how to estimate. All right, so let's do a long division problem. I'm going to take my divisor as 1, 2, 3, my dividend 84,378. How were you taught how to divide this? You don't know your 123 times tables, do you? You were taught to round the divisor, right? If you've heard our academy students, they do these steps. Here's the steps in the procedure. Estimate, divide, multiply, subtract, compare, because your remainder cannot be bigger than your divisor, and then you bring down the next digit and start all over. All right, so we have our 6 steps to doing a long division problem when the divisor is not a single digit. We have to estimate, because we're not going to always know what our divisor goes into our dividend exactly in. So I want to give you some guidelines for estimation. Here's the problem. We don't estimate efficiently, so we end up having to trial and error. Well, trial and error is not really a math skill. It's kind of like guessing is not a math skill. So I want to give you some estimation strategies to help you with your own long division. Because just like any other student, nobody likes to do long division. All right, 6th graders, 5th graders, 7th graders, they dislike long division because they're inefficient with it. So some estimation strategies. Yes, we will round the divisor, but let's refine this a little bit. Rounding the divisor does not always have to go to the first digit. We want to round the divisor, first of all, to a convenient number. Not just whatever the first number is. This one, it's convenient to use 12 in the estimate, not 1. Okay, so we will round the divisor to a convenient number. You might be able to round it to 12. All right. You might sometimes be able to round it to 25. And we all know what quarters are, and we all kind of can figure out how many quarters in a certain dollar amount. We can use, don't forget, you do know your 12 times tables, don't you? You do know your 11 times tables. You might be able to do some dividing in your mind with 25. Okay, so you don't have to follow the rounding rules exactly. You want to round to a convenient number. Of course, I'm using the Bob Jones curriculum to teach 7th grade math, and they teach estimation for division in general, not just in a long division problem, and they will say to round both the dividend and the divisor to compatible numbers. So we don't have to follow the rounding rules explicitly because we're not rounding. What we're trying to do is get a close idea of what that quotient is supposed to be. We don't have to round. We don't want to blindly round. These aren't steps that have to be followed. These are strategies to make our estimation easier, faster, more profitable, so we're not spending too much time on a long division problem. All right, many times on tests here in college level or my math placement test, students skip the division. It takes them too much time. Okay, so what we're going to do is we're going to learn how to divide faster. So yes, usually the first technique that you're taught when you are doing long division is to round the divisor. So I want you to understand that we can round it to a convenient number, such as 12. That's going to give us a much better way to divide. And sometimes we may not even need to estimate. I'll show you a couple other problems. So this doesn't have to be done. So often we should round to a convenient number. We may not even need to round. And then here's what I want you to especially learn about rounding the divisor. It's just the starting point. Rounding the divisor is just the first strategy. It's not a step that we have to do. We may not need it. And we don't want to follow the rules of rounding precisely. We want to round to a convenient number. We don't have to obey the rounding rules. And it's just the starting point of our strategy in estimating quickly and accurately and cutting down on your trial and error. Often students, 4th grade, 5th grade, and you're not teaching that, but you'll see it in 1st and 2nd grade. Too much trial and error. 1st and 2nd graders especially, but even older students are not very good at erasing. And you will get the paper back and it will have been destroyed with erasing. So we don't want to be doing the erasing. So the first strategy, yes, is round the divisor. So we want to round that to a convenient number. Do we need to round? And keep in mind that it's just the starting point. Then I have a caution with rounding the divisor. The caution is this: the more you round, the less accurate your estimate. The more you round, the more suspicious you need to be of your estimate. So the more you round, the worse and worse the estimate becomes. So you need to become more and more suspicious of it. The more you round, the less likely your estimate's going to be accurate. What do I mean by the more you round? Well, let's say I have a divisor of 35. What do the rounding rules tell me to do? Round up to 40, right? That's a big round. So I would be suspicious when I've done a large round when I'm using 4. I'd be using 4 in my estimate in my mind, wouldn't I, if I had 35 as my divisor. In this case, I'm going to get a very nice estimate because 12. What if I had 39 as my actual divisor? I would still use 4, wouldn't I? But is this going to give me a more accurate estimate for 39 or more accurate for 35? Do you understand what I mean by the more you round, the less accurate your estimate becomes? If my original divisor is 39 and I'm using 4, I'm going to be pretty confident with that estimate. But if my original divisor is 35 and I'm using 4 in my estimation step, I'm going to be suspicious. Same thing with 34. If 34 were my divisor, I would kind of round down to the 3, wouldn't I? See, so rounding the divisor, we have to have a caution involved with rounding the divisor. It's not going to be an automatic thing that's going to give me the correct estimate every time. It won't work. It's only the starting point. And so the more I round, the less and less accurate my estimate becomes. This is a big round up, isn't it? It's right on the border of my rounding rules. So I'm going to be suspicious of using 4 when the divisor is 35. This is also a big round. It's also on the border because if I have 34 as my original divisor, I'm going to use 3. But this 4 is going to cause me some problems, isn't it? Now, if my original divisor is 31 and I'm rounding down to 3 for my estimation, it's not too bad. So the more you round, the less and less accurate your estimate is, and the more suspicious you should be of it, and the more you need the second strategy. Okay? The second strategy is to, yes, we're going to round. That's our starting point. The second strategy is to consider the dividend. We don't just want to blindly round our divisor and try it, see how it works. That's trial and error, too much trial and error. So I want to consider the dividend. What do I mean by this? I'm going to consider the dividend. I'm going to look ahead and I'm going to think, okay, how many times does the estimate go in? Does it go in exactly? Or is there a lot of what I'm going to call carrying room? So I want to consider the dividend. Let me show you exactly what I mean by that with this illustration. 12 goes into 84 exactly 7 times. So that tells me that I am not using 7 as my real quotient. There's no carrying room. So if my estimated divisor goes into my dividend exactly, there's no carrying room. So I need to consider how accurate the estimate is. If it goes into 84 exactly, there's no carrying room, not round, room. There's no carrying room. I'm thinking in my mind, 12 goes into 84 7 times, so 123. That's not going to be, I'm going to go skip down to 6. Because 7 has to carry a 2, and there's no carrying room. So I am not going to bother with the 7. This isn't even that bad of a round, but 12, when the estimated divisor goes into the dividend exactly that number of times, that estimate will be too large because there's no carrying room. So unless this other digit here is a 1, maybe a 2, and I don't have to carry, so I have to pay attention. Do I have carrying room? Because I'm going to almost always need carrying room, so I'm going to automatically go to 6. Okay, so 6 times 3 is 18. 6 times 2 is 12. Carry my 1, that's going to give me 7. Then when I do the subtraction, I get 105. So I estimated, and I actually was able to get my division correct the first time. Multiply, subtract, compare. 105 is less than 123. Bring down my 7. And then I'm going to start over. All right, so how many times does 12 go into 105? 8 times, right? Carrying room? Yes, because 8 times 12 is only 96. So I'm confident with the 8. I have carrying room in my dividend. So I round to the 12, and then I consider what's going in. I'm going 12 into 105. Plenty of carrying room. Ooh, I can also be sure it's not too much carrying room. What am I going to carry? 8 could even be too big, but probably not. I'm going to carry, what am I going to carry? I'm going to carry a 2. Okay, so that's going to give me 98. I'm going to be okay with that. So when I multiply, I'm going to go ahead and use my 8 because I have carrying room. So see, my mind is active. My mind is active the whole time I'm doing math. And students sometimes are a little resistant to that. They don't want to engage their mind. They want to do rote steps on autopilot. And because division cannot be done on autopilot, it's disliked and it takes too much time and so forth. So we want to engage our mind. We're not just going to blindly round and start and see what happens. We're going to keep considering not only how do I round, but what is going on in that dividend. Do I go in exactly? Do I have enough room to carry? I'm going to be carrying a 2. So then 8 times 3 is 24. Carry that 2. That gives me 18. And this is going to give me, what? 73. And that brings me to my third strategy. Here's the second strategy. Third strategy is to anticipate the product that I'm going to be getting. I just did that a little bit. I anticipated the carry of the 2. Anticipate the product, and the third strategy plays a direct role in what I'm going to show you next, and that is pay attention to what you just used. I need to get myself made a nice sign that says pay attention. Because that's my biggest problem teaching math, is students not paying attention to what they're told, and in this case I'm talking about they're not paying attention to what they're doing. So pay attention to what you're doing, pay attention to what you just used. Hello, what am I going to do? What am I going to do? Just put the 6 up, I'm done. But many students don't even notice that because they're not paying attention. So yes, we're going to round, but that's the starting point. Then consider the dividend. Then anticipate the product. And then pay attention to what you just used or what you just did. I already used the 6. It's going to work very nicely. So I'm not even going to finish that. I got my quotient. Okay? So the biggest part of long division is paying attention to what you're doing. You need to pay attention to how much you rounded. You need to pay attention to what's in the dividend. You need to pay attention to what you're going to carry and what your product is going to be. And then you can get a lot faster. And less erasing and less frustration. But then the other problem with long division is a little bit of weakness in the times tables. And making time mistakes with common factors and products. All right, so let's do a few more examples. So yes, we will round the divisor. That is our first strategy, but it's just the beginning. Let's try 342 as our divisor. Our dividend is 297,882. So one of my goals is to help you think through the problem and show you some things that you can do to make your mind engage itself as you are dividing, not just doing rote procedures. All right? And is this something that people naturally do? No. We all want to be told, just tell me what to do and forget the rest. I just want to do this, 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 this. Get it done, check it off. All right, so long division is where it kind of catches students who don't want to use their mind. So what we're going to do is we're going to help them to use their minds. So my idea here too is not that you don't want to use your mind as a college student, but to help you have some things just to help you go faster. All right, and you might, yes, you are teaching primary math, but you might get 5th grade for student teaching or 4th grade. Division's a big part of 4th grade, teaching the estimation. And then it needs to be retaught in 5th grade. So let's try 342 into 297,882. So by straight rounding, I'm rounding this down to 3, right? But think about it. I'm dropping off of 42. So I'm going to be suspicious of my estimate from the very beginning. Highly, highly, highly suspicious. I am not wasting my time on 9. How many times does 3 go into 29? 9 times, right? And there's even carrying room. But this is a big round. I dropped the 4. So that means I'm going to be carrying. If I carry, anticipate the product. Yes, there's carrying room in the dividend, but anticipate the product. If I use 9, I am carrying a what? Think about it. If I use 9, I'm going to carry what? 9 times 4 is 36. Do I have room to carry a 3? So I'm not going to waste my time. I am dividing, I'm going to think, yes, 3 into 29, but I'm really dividing 342 into 2,900 whatever, right? I am not wasting my time on the 9. I don't care that 3 goes into 29 9 times. 3 times 9 is 27. I know I can't carry the 3. Not enough carrying room, so I have to consider the dividend. Okay? Yes, it's true that 3 goes into 29 9 times, but I'm very suspicious because the more I round, the less and less accurate my estimate becomes. I will not waste time on 9. Hopefully you wouldn't either. But what about 5th graders? What about 4th graders? Especially 4th graders. They're going to put the 9 up there because I'm supposed to round. All right, so then when I do the actual multiplication, I am carrying a 3, so that gives me 2736 when I multiply that out. And when I subtract it, I get 242. Okay, now I'm going to bring down the 8. 3 goes into 24 how many times? 8. Why would I even use the 8? Pay attention. Am I going to use 8? I already did use 8. What am I going to use? I'm going to automatically drop down to 7 for 2 reasons. I'm paying attention to what I just did. I just used 8. And 3 goes into 24 exactly 8 times. No carrying room at all. So I'm going to drop down to the 7. And 7 is going to give me 2394. Fits nicely. Then when I subtract, yay, pay attention. That's actually my divisor. Okay, so the more you engage your mind, the faster you're going to be able to do the division problem. And it's not just step 1, step 2, step 3. That's not the way it works. So we kind of have to balance our rounding rules with what's in the dividend, what I have to carry, is there enough carrying room, and I have to pay attention to what I just used. I'm going to use 8. And I always want to pay attention, can I use the same quotient a second time? So division, with practice, yes, we'll get faster and faster, but it'll be even better if we practice estimating with our students. Okay, so I rounded down. So remember, you have to have a caution with rounding. The more you round, the less likely you're going to get the correct quotient. So with rounding, if you round down, you have to watch out. Your quotient's going to be too big. If you round up, you have to watch out. The quotient could be too small. So be suspicious of just using the rounding rules, because we're not really rounding. So the more I round, the more suspicious I am of my estimation. The less I round, the more confident I can be. So let's try 47 as a divisor. 47 into 324,065. If we're good at our just basic long division, then we're not going to have so much trouble with the decimal math. We can just concentrate on decimals instead of having to figure out what I'm doing. All right, rounding rules puts this up to 50. So I'm thinking about 5, right? How many times does 5 go into 32? It goes 6 times. 6 is going to be okay. Why? 6 is going to be okay. Why is it going to be okay? What do I have to carry? What am I going to carry if I use 6? I'm going to carry a 4. And what's 4 times 6? 24. Do I have enough carrying room? More than enough. So this 7 is pretty close to 5. I'm going to be very confident with my 6. Why? I have carrying room, and I know I'm only carrying a 4. And 6 times 4 is only 24. Look where I'm heading. I'm heading to 32. So I've got plenty of carrying room. This will give me 282. When I multiply, and I subtract to 42. Bring down 420. Okay, how many times does 5 go into 42? 8. Carrying room? Sure it is. There's plenty of carrying room because I'm only going to 32 and I have 42. So 8 works fine. Plenty of carrying room. And then 8 times 7 is going to be 376. Then when I subtract, I get 44. Bring down my 6. All right, 44. Pay attention to what I just used. Is 8 big enough? It's not. It's not. 8's not big enough. I just used 8. Is 8 going to get me to 44? No, so I'm going to go to 9. I'm looking at what I've already used. This product, I don't have to anticipate the product. I have the product. 376, think about it. $376 is going to put me at 70. Way twill big. Way too big. This is way too small. So I pay attention to what I just used. I'm not going to waste time with the 8. This will give me 423. Look at this. 423. So what am I going to use now? I'm going to go back to what? Once I subtract, I'll go ahead and do the subtraction, I get 23. Bring down, I got a 5, bring down the 5. What am I going to use? Here's 6. So what am I going to use? 5 goes into 23. How many times? 4. Okay? What's the product going to be? Here's 6. 4 is going to be too small. I'm going to go right to 5. Another thing, if they don't tell you about the remainder, it implies that the division comes out even. Look at this number, 5. 5 times 7 is 35. Look at this. Anticipate the product. 5 times 7 is 35. Carry the 3. See it? Comes out even. It's exactly 235. Doesn't fit there, but take my word for it. All right, so when you're rounding, you want to be always progressing through a thought process. Math is not done by rote steps. Maybe at first, with primary, we can teach them rote steps, but that's not what math skills involve. Math skills involve thinking things through. So if we have some ideas of things we can be looking for, things we can be thinking about, we can teach students to think about what's in the dividend, not just think about the round. Think about what you're going to get when you multiply. Pay attention to what you're doing. Use what you've already done to help you make an estimation decision. Okay, so long division is a very important and it's useful, very useful as far as what we're doing. Another thing that I want to go over with you is something that's called short division. And this is a mental math. Short division is used when the divisor is a single digit, and short division is important for prime factoring and things that you need to be able to do. So when you're doing division, yes, this takes off as far as teaching is concerned. It's not going to take off till 5th grade, and that's not the topic of this class, but your own math skills are just as important as a 1st grade teacher as they are if you're the 6th grade teacher. So make sure that a lot of times the division skills are lacking, and that's why we're covering it. So let's do short division. Some other considerations in division. The biggest consideration that you have to do is, can you estimate quickly and accurately? Now some other considerations in division, and the first is short division. Short division is mental math. Short division is we are not going to write out the multiplication and the subtraction or even the bringing down, really. We are going to do it in our mind. So short division is mental math, and it'll help you yourself for your own division skills, especially if we're going to prime factor. Okay? So, and we can use it. I have this example here. Sometimes too, you'll even see it written upside down so that you can't write your product and so forth. Let's take this. Let's do 9 into 33,075. Okay, short division requires us to do the multiplication and the subtraction in our mind. So 3 goes into 33 how many times? I'm sorry, 9 goes into 33 how many times? 3, 27, right? So 9 goes into 33 3 times. What's left? 27. 33 minus 27 is 6. So then I put my 6 here because 6 is the remainder. So this involves mental math. I do the 33 minus 27 in my mind. I get 6 and I put it here. So then my next division is 9 into 60. How many times does 9 go into 60? 6 times, right? What's 9 times 6? 54. So I'm going to use 6. 54 from 60 is what? Another 6. So my next division is 9 into 67. How many times is 9 going to 67? 7 times. That's 63. 4 left over. 9 into 45 is 5. That's short division. It's mental math. Okay? And whatever grade you're teaching, and even for yourself, a lot of your oral drill and a lot of your class time needs to be sharpening their minds. What does this do? It sharpens your mind because it forces you to not see what you're doing. This is mental math. I am not seeing this. I've got to start doing that in my mind. I'm not seeing the multiplication or the subtraction or the bringing down. I'm bringing up. Okay? Same thing here. I am not seeing this. I'm doing it in my mind and bringing it up. All right? And I'm not seeing 67 minus 63. I'm doing it in my mind and bringing it up. Okay? Short division is a form of mental math. It sharpens the mind. Okay? And the problem with long division that we're tripping over a lot, some of you haven't had arithmetic or had to do a whole lot of math in a while. And so we're tripping over our times tables, right? We're tripping over our mental math. And you've got to sharpen your mind. Okay? Let's do another one. Let's do 5. The 5th graders learn this and the 6th graders learn it. And even this year's 7th graders, they said, can we do mental math? Can we do short division? Do we have to do long division? Because I was making them show their work. Simply because we weren't having very much success in some of our grades. But this is a good thing. It sharpens their mind. What about your mind? We're dealing with your mind today. 5 into 30, how many times? How many?
6.
What's left? The 5s are easier. 5 into 17, how many times? What's left? 2. Okay? And so we want to make some things a little bit fun. And the reason that you need to be able to do so-called short division is prime factoring. Let's say I have, I'm going to do 361. Prime factor that. Prime factor means to take a composite and break it into whatever prime factors it's going to be. How many 2s, how many 3s, etc. So we're going to use division by primes. And this involves dividing by the prime numbers. 2, 3, 5, 7, 11, and even 13, even 17 sometimes. Okay? And so I use my divisibility rules. Do you know your divisibility rules? First and most obvious is the divisibility rule for 2. These rules are stuff that we start teaching in 3rd grade, maybe 4th grade, definitely by 4th grade, but we could even start with primary. To divide by 2, what has to be true of the dividend? It has to be an even number, right? So anything that divides by 2 has to be even. So in my short division problem here, that I'm going to start to prime factor 361, do I bother with 2? Do I bother using 2? Normally when I prime factor I start with 2, but I'm not going to do that here because it's not an even number. 2 doesn't work, I'm going to proceed to 3. What is the divisibility rule for 3? Sum the digits. So if I sum the digits, and that divides by 3, the entire thing will divide by 3. Okay? So does this divide by 3? Three plus 6 is 9, plus 1 is 10. So I can't use 3. Does 5? 3 didn't work. Does 5 divide? What am I going to do for 5? It has to end in a 0 or a 5. No. What about 7? No divisibility rules for 7. So, 7 into 36, 5 times. Oh, 35, that doesn't work either. What about 11? 33, carry a 3 up. No. What about 13? 13 times 2 is 26. That leaves me at 10, 101. What about 17? 17 twice is 34. No. So guess what kind of number this is? In and of itself, it's already a prime number. How are you going to know that if you can't quickly and accurately divide by primes? We do have a divisibility rule for 9, right? What is the divisibility rule for 9? What is the divisibility rule for 9? Sum the digits also. You know why? If the sum of the digits divides by 9, then the whole thing divides by 9. Because 9 is square of 3, right? So if we use the same rule for this 3, we can apply it to 9. Is there a divisibility rule for 6? Not per se, but we could make our divisibility rule for 6. What would our divisibility rule for 6 be? What should we combine? 2 and 3. So if it's even and the sum of the digits divides by 3, then I know the whole thing divides by 3. So if I'm going to make up a problem, I kind of need to know my divisibility rules. I also have the divisibility rule for 10, and that has to end in 0. Can't end in 5 because 5's not even. So I have to put the 5 rule with the 2 rule. So it can only end in 0. 0's even, 5 rule is not. So let's use some short divisions for some more prime factoring. Okay, let's say that the number is, well, I'm going to do we're going to do 3, 6, and then I'm going to do I want the sum of the digits to divide by 9 so that I can make a number that is a multiple of 9. So 3 plus 6 is 9, add another 9. So let's use this and let's prime factor it. Not wasting my time with the 3. Pretty easy. Does that divide by 3? Of course it does, because it divides by 9. And sum the digits. 3 plus 3 is 6, so this continues to divide. 3 goes into 12 4 times, 41. 41, is it a prime number? How do I know it's a prime number? Does it divide by 2, 3, or 5? Then it's not going to divide by anything else, especially not that small. So we learn prime and composite, but we have to start using these things. Okay, so short division is used for division by primes. And we need to know our divisibility rules when we consider. Another consideration with division is different ways to show division. Okay, so we have short division, we have showing division. How can we show division? How many different ways? Just have a couple minutes here. We can show division with the division bar. Either way. Long division, short division. But then we also have to practice using the division sign and the fraction bar, and we need to be able to go back and forth between all of these. So I can do 36 divided by 12, or 36 divided by 12, or 36 divided by 12. So we have to be able to, and we have to teach this. Where is this taught? Primary. And this has to be added later. And so even different ways to show division and different ways to keep track of dividend, divisor, dividend, divisor, dividend, divisor. This is something that has to be taught. It cannot be assumed. Otherwise we have problems. Here's the dividend. Here's the divisor. Here's the dividend. Here's the divisor. Okay, don't assume, and make sure you teach even little things like this. I say, well, if we don't know this form, who knows? Can anybody tell me? I've made a mess here with my circle. Let me go ahead and start over. Let's do the same numbers. 36 divided by 12. We have to be able to go this way. 36 divided by 12. And we have to be able to eventually go this way. Can anybody tell me when this is going to play a role? If we don't learn this in primary, when is this going to hurt students? Well, I know because I teach different levels. So take my word for it. I still have problems with 7th graders who can't do fraction division. Because it seems like they don't know which number's the divisor. And it starts hitting them when we get to fractions, both ways. And often students can't, let me use this, they can't remember how to convert a fraction to a decimal. That boggles my mind, because what does this bar read? How can I read this? Besides 7/8, I can also read it 7 divided by 8. Can't I? So how do I go from 7/8 to its decimal equivalent? I do the indicated division, but so many students don't know that that's indicated division, do they? And so on my math placement test, they leave that problem blank. I can't remember how to change a fraction into a decimal. You're not supposed to remember. You're supposed to know the different ways to show division. This is how I get the decimal equivalent, 0.875. Not by remembering how to change a fraction to a decimal, but understanding different ways to show division. And the last consideration for division is decimal division. And even fraction division. We've already covered the fraction division, but you'll have to, on the tests and quizzes, you will have to divide by decimals. Okay, so that just throws another kink in long division. Remember, you cannot divide by a decimal in the dividend. In the divisor. The dividend, if we start with just the dividend, we know that we bring the decimal up and do our division, but you cannot divide by a decimal. You have to move the decimal out. And if you think about it, when you see that division problem in decimal form, I'm moving this one place and I'm moving this one place. So then my problem has to be rewritten as 35 into 475. Then I have to add zeros and round where I'm told to round. So don't forget some expansion of your long division. The decimal goes up to the quotient, but not yet. No decimals in the divisor. Move it out. And actually all I'm doing here is I'm multiplying by 10. And if I multiply by 10 in the numerator, which is the dividend, because I multiplied by 10 in the divisor, which is the denominator. Okay, so we have to be good with division. Whether we're talking our regular estimation skills, can we do short division? Can we show division different ways? Can we apply long division to decimals? All right, we'll see you on Friday.